Welcome to today's webinar, AI-powered predictive maintenance for asset-intensive industries, brought to you by Oracle, Trinamix, and rfsmart. First, let me introduce myself. My name is Wade Wilson, Director of Global Business Solutions at Trinamix, and I'll be your moderator for this webinar today. Today, we will discuss the use of AI and machine learning for predictive maintenance to provide cost savings and proactively resolve future breakdowns before they happen. I'd like to introduce the panelists. Our first speaker is Simon Nicholson, Senior Director of Product Management, Intelligent Application Development at Oracle. The second speaker is Vinod, Director of Solutions and Sales at Trinamix. The third speaker is Aaron Levin, Director of Product Management, Intelligent Application Development at Oracle. And then we will have Christian, Oracle Cloud Sales Executive, and Dathan Goff, Senior Solution Consultant, speak from rfsmart. We will have poll questions throughout the webinar and a QA section at the end of the presentation. We would like your participation. You can post any questions within the Q&A section of the webinar, and the panelists will answer those questions after they have spoken. The webinar will be recorded and a link will be provided to all attendees today. Your mic will be muted. We will start with poll question 1. Where are you on your cloud journey? 1, we are investigating cloud ERP solutions. 2, we are implementing Oracle Cloud. 3, we are live on Oracle Cloud. And 4, I am an implementation partner. All right, the poll is now closed. We will begin the webinar by having Simon Nicholson from Oracle, who will speak about the approach of how companies are performing predictive maintenance. Please welcome Simon.
Thanks, Wade. Hello, everybody. Good morning or good afternoon. This is Simon Nicholson, Senior Director at Oracle Corporation within the Intelligent Applications Development Group, responsible for product management. And I think building and sort of trying to set the scene today, what I'd like to talk about is a framework for reliability for assets and around the whole notion of predictive maintenance. Now, before digging into that, I think the first thing to do is actually let's define what we mean by assets, because they're one of the largest items of expense, whether it be capex based or opex based, across most of the enterprises out there. And assets can be stationary, they can be nailed to the ground, they can be fixed to the ground, or they could be moving about. On the right-hand side there, they're the assets that we utilize to run our businesses, the enterprise assets that we own ourselves or that we lease. But equally, on the left-hand side, there's the assets we provide out to our customers, whether they are actually the product or whether they are an expression of the product. And I think in all cases, one of the key considerations about this is how we actually track the location of the assets. I mean, what's important? Well, location's important. If it's stationary and it starts moving, that might be an indication of something's fairly severely wrong. Or equally, if it's moving, it's supposed to be moving and it's not, equally, we might not be enjoying full utilization of the asset. And it might be representing more, becoming more of a cost than a benefit to our business. But really what drives all of this is availability and reliability, because if the asset's neither reliable or indeed available, then we're not getting any utilization, and really it is totally a cost to us all. And I think something maybe that at some point in our lives we may have experienced directly. I mean, here's an unfortunate situation. Cars serviced regularly, seemed okay when I left home. However, here we are, stuck by the side of the road, pondering on what to do next. And really, it's the pondering what to do next that sort of sets the scene here. Sort of we go through various maintenance regimes, but the question then becomes is what's the right time to actually conduct maintenance? I could have maintained something last week. Indeed, I've had conversations with folks, and they've said, how often do your assets fail? The answer is never. How often do you maintain them? Well, very, very regularly. In fact, perhaps too regularly. The thing is perpetually in a sort of maintenance regime, which is maybe overdoing it. But equally, you could be leaving it far too late, leaving to increasing levels of unreliability or indeed failure, as happened to me previously. Something I've written about in a recent blog posting on the IoT blog at Oracle. You've left it too late. So what is the right point around timing of maintenance? And I think a key consideration of that is what is the impact if it all goes wrong? I mean, what is the impact of an unplanned outage? Well, certainly the industry figures are startling. Average cost around roughly around $1 million, partly born of the fact that the average downtime is around 4 hours. And this isn't just the cost of not having the asset available; it's all the rollout costs. It's like the ripples on the pond that extend away from where the rock entered the pond. In terms of things like the impact it has on staffing, the impact it has on overtime, maybe additional resources need to come in, maybe you need to offload work to somebody else. The maintenance activity, there's inventory impact. If it's an unplanned outage, for example, in manufacturing, you might have to rerun an entire production run. It may have impact on insurance. It may have impact on your relationship with your customers. It may lead to sort of SLA penalties, etc., etc. And on that last point regarding SLAs, I mean, in that source of the Machine Metrics survey a year ago, nearly half of the companies surveyed actually couldn't deliver the services to their customers. They weren't actually able to do the very thing that they were in business to do. And really, if we look across on the left-hand side, what's intriguing about this is that still 3/4 of the companies out there are relying on break fix or preventative maintenance, not in control of unplanned downtime, or indeed when assets are due to be maintained. Now, we can look at the sort of a maturity model here. Obviously, starting with reactive, preventative. Reactive, break fix. Preventative is, I take the car in every 12 months and have it serviced. But really, neither of those accurately take into account what's truly going on with this asset. So condition-based is appealing. That says, what is the current state of it right now? Does it need to be maintained? Even better is predictive. What is the likely state of it going to be in a week's time, in a month's time, and so on? And off the back of that, we can then start to be prescriptive, because you can actually identify what maintenance is needed and when, looking forwards, and potentially actually starting to remove, advising and removing maintenance tasks from the plan. For example, at the moment, we may have our car booked in to be serviced next week, but haven't used it a great deal in the last few months. Garage looks at it and says, well, we're looking at the status of things, and actually your car's in great shape. You don't need to come in for that maintenance, which is a great customer service offering, especially if they underwrite that. So it's just an example of how you can move beyond predictive. But how do we actually get to predictive maintenance? And really, it's all driven by the availability of data, like predicting anything. I mean, weather's a great example, the weather. If you're going to predict the weather, you're going to need more than 1 day or 1 month or indeed 1 year of information to be able to accurately forecast what the weather's likely to be doing in your part of your neighborhood in any given moment. And it's a similar story with assets. So the first thing to do is, as quickly as possible, is start tracking the performance of the assets. So actually starting to acquire data, generation of metrics as to what's acceptable. And then off the back of that, you're going to start to see moments where everything's working fine, and you're going to see moments where everything's working not so well, including where you're breaching certain spec limits, but also where the data's actually trending or moving, anomalous activity, where you're starting to see, well, that doesn't look right. It hasn't actually broken any rules, but it doesn't look or feel right. And you're going to start to build up these patterns, this inventory of information, this base of information off which you can then start to make predictions. We've seen what good looks like, we've seen what not so good looks like, and therefore we can start to generate those predictions in terms of what failure might look like, not just based on sensor signals, but as indicated by this timeline here, based on the contextualized data that you can also bring in from external. And where that then takes you is into the opportunity to start looking at things like optimizing maintenance, as I just indicated on the previous slide, where you can actually start to say, well, maybe we don't need to maintain that particular asset right now. It seems to be doing fine. Whereas another asset, which is maybe getting a lot of utilization, isn't due to be serviced for 4 weeks. Maybe we want to bring that forward, because otherwise we may not actually get to that 4-week point in time. But we can go beyond that as well, because predictive maintenance can advantage other aspects of our operation. Sustainability. What is the right time to maintain something? Might be born of the fact, what's the right time to dispose of something? Or indeed, you might want to maintain something slightly earlier because you're starting to see it's consuming higher levels of energy than would otherwise be the norm. Hasn't broken, it's still working fine, but it's actually your energy bills are rising, as an example. Inventory. you can advantage inventory, because if you know, rather than waiting for something to fail and then realizing you need to rerun the entire job, obviously, if you've got that predictive capability, you can plan your inventory accordingly. And not just the inventory if you're in manufacturing, but your inventory of spare parts, for example. Many folks are looking at this as a way of reducing the levels of inventory they're having to carry in the case of any eventuality, for example, in the vehicles that service their network for their customers. The number of guys out there driving, customer service people driving around out there servicing parts, which plays back into customer service. You're delivering a high level of customer service, and in some cases actually being able to preempt issues and actually maybe advising the customer on changes in behavior which will result in an issue never occurring. And then finally is the quality piece, not just the quality of the operation and the service you're delivering to your customer, but potentially the opportunity to improve the quality of your product, or indeed examine the bill of materials that you're deploying in your product. And it may be that mean time between failure was estimated in months, and you're actually getting years out of it. So maybe you've over-engineered certain parts, and you might actually be able to adjust your bill of materials accordingly. So a lot of opportunities come from this. And in terms of the Oracle solution, it really falls into 4 areas. We've got the IoT intelligent apps, specifically asset monitoring in this case, which is providing that real-time monitoring and predictive capability. I'll return to that shortly. But it's the integration that offers also with other parts of the supply chain, the Oracle supply chain, or indeed third-party supply chains, and then how that informs the field service organization to actually increase the efficiencies of field service operations. For example, better improving towards the whole notion of a first-time fix. When the engineer goes out, they fix it, they've got the right parts, the right skills, they're there at the right time, they know what to do, they can fix it first time and not have to sort of book those repeat visits that are can be so expensive and so detrimental to the customer experience. And then finally is bringing that all together in terms of understanding the financials and the costings around this, the value that we're deriving from the asset, and how much we're actually spending on maintaining it, and indeed when's the right time to drive towards a replacement. But before just finishing up, if I look at the IoT applications in terms of what they provide, certainly there's the acquisition of data and the sort of derivation of the virtual twin, the digital twin, that we then use to derive the understanding of what's the data telling us in terms of how we actually utilize that within domain-specific dashboards, and the utilization of the KPIs, whether they be the standard KPIs or whether they be the KPIs that you yourselves, the customers, derive for themselves. That provides a certain level of value, but really it's not the full story. The full story is on the right-hand side of this chart, is when you start to look at how we apply the data science in a box capabilities that are part of the product, that utilize AI and machine learning to start actually helping you identify anomalies, identify trends, but then more critically, especially in the predictive maintenance world, is that predictive analytics and the recommendations as to what you should do about it, and then how you actually finalize that and really complete the story, which is the action and the activity that this drives, the automation of that activity within the enterprise apps over on the right hand side. And really we could argue that unless you're actually driving events and actions and context specific direction to the business users and the enterprise users, you're not actually deriving full value from your IoT data that you acquired on the left hand side there. So really, in summary, in terms of what's the value, well, predictive maintenance really is a game changer. I mean, this is coming from some work Deloitte did a few years ago, and there are plenty of similar studies out there that basically say it really does it really does drive optimizations in the way that you're working, and actually provide that scope to actually grow your business. Equipment uptime, 20%, a fifth more of value coming back from your equipment, which obviously has a corresponding knock-on effect onto productivity. And nearly 3/4 of breakdowns reduced, removed. And if I go back to that $1 million an instance type figure, that has real value back into the bottom line. And finally, it's the reduction in the maintenance costs, which are operational costs that free up capital to potentially do more creative things with your customers, to expand the value proposition back to your customer. So with that, many thanks for your time, and I'll now hand back.
Thank you, Simon. We will now hear from Vinod from Trinamix, who will discuss Industry 4.0 and how asset-intensive companies are utilizing IoT and asset monitoring to decrease costs and increase production. Vinod?
Thank you, Wade, and thank you, Simon. Today, what I'm going to do in next 5 to 7 minutes is to do a brief introduction on Trinamix, then jump into challenges faced by asset-intensive industry, and then how Trinamix can help with modeling sensor data into IoT lab and help companies embrace predictive maintenance. In the end, I will also address how latest hardware technology can connect remote locations to the IoT platform. So Trinamix is a platinum partner with Oracle with global presence in US, UK, Canada, Australia, and India. We are the #1 partner with Oracle in supply chain space, which includes maintenance and IoT solutions. In Canada, we are based out of Calgary. So if we look at asset-intensive industries, they have expensive assets all around the world. Most of the locations are remote with limited internet and cellular network. There is a significant investment in the MRO inventory, and machine downtime can be detrimental to the bottom line of the companies. A lot of companies have invested in installing sensors on these assets, but we also see that they're struggling with applying artificial intelligence and machine learning on this data. The traditional ERP systems are lagging in providing capabilities to provide an integrated solution between IoT platform and maintenance solutions. So, what do asset-intensive industries desire, right? They want connected assets so that they can measure, analyze, and predict the failures and move from a reactive to predictive to a prescriptive maintenance schedule. So in order to do that, they need sturdy solutions to cater to remote locations and extreme weather conditions, a modern asset tracking, asset maintenance system, which provides ease of maintaining assets through their life cycle. This would result in improved uptime, reduced outage cost, and effective working capital management for the installed assets at the sites. Now, along with the IoT platform, which was discussed by Simon, Oracle provides a complete and modern cloud-based maintenance solution, which is integrated with Oracle's ERP to provide an end-to-end integrated solution across IoT predictions, generating predictive maintenance schedules, and the back office linkage to supply chain management for maintenance. Within the maintenance cloud, you can create assets, maintain asset location, maintain asset history, as well as enable assets for Internet of Things. Maintenance schedules can be created via predictions from IoT platform, or they can be created within maintenance cloud. Maintenance part list along with work orders are created and executed within maintenance cloud. Maintenance cloud is also integrated with Oracle ERP via inventory management, procurement, cost management, and field service. Now, we see in the market a lot of companies are evaluating IoT solutions. Trinamix helps corporations by modeling the physical setup in a lab setting to create digital twins and demonstrate how sensor data can be fed into an IoT platform to generate insights. This automates creation of predictive maintenance schedules. Inventory needed to support the schedule can also be planned within the Oracle solution footprint. Here is an example of modeling for an asset-intensive site. As you can see in this site, you can see some drilling rigs or smelters could be modeled, some heat exchangers, boilers, earth moving equipments, oil pumps, conveyor belt, solar panel, office assets, control room equipment, and some of the raw material and spare parts inventory in a lab setting. Now, once you have modeled this, now let's dive into a day in a life scenario for different personnel across hierarchy. and how Oracle application landscape has enabled each of them to monitor and manage production, maintenance, health status of the assets. As part of a daily routine, the time is used to review performance like equipment capacity, equipment utilization, maintenance, safety, etc. The IoT application, on the other hand, can empower by providing all the information in a single pane of glass on a real-time basis. What this would do is it would help them to get text notifications for anomalies, for drilling rigs, smelters, which may have high temperatures, and you would know the exact machines which are impacted. And what it would do is, and then you can send the same to service technicians, and the service technicians can be dispatched to investigate and perform maintenance activity. In addition to this, additional benefit is worker safety. The alerts can avoid accidents on the sites through early warnings. Now, to enable all this technology, you need hardware. And one of the challenges that we have seen with the asset intensive industry is connecting remote sites to collect real-time data efficiently and economically. Here I'm presenting an alternative technology which is called low radio frequency long range wide area network, also known as LoRaWAN, which leverages this free radio frequency spectrum to connect remote locations with IoT applications. This technology has wide applications in remote equipment tracking, vehicle telematics, etc., and can be used in mining, oil and gas, forest products, construction. Here is an example on how low radio frequency wide area network can be used to make mines safe. As you can see, Rio Tinto has embraced this technology for connecting its conveyors. Cisco is delivering remote monitoring of assets with this technology. In Canada, the city of Calgary has deployed the same low radio frequency technology to remotely monitor water levels in the Bow and Elbow River as early flood warning system. They are also using the same technology to track noise pollution, monitor climate at Devonian Gardens, and also monitor golf carts at the Shaganappi Point Golf Course. Thank you.
Thank you, Vinod. We will now hear from Aaron Levin from Oracle, who will speak on Oracle's intelligent track and trace solution. Please welcome Aaron.
Great, thanks, Wade. Hello, everybody, and thank you for your time today. So I'm going to be talking about another product that is part of the Oracle Intelligent Applications portfolio. So this is a product that is tightly integrated with the IoT applications that Simon talked about, as well as our other SCM applications like Maintenance Cloud and Manufacturing Cloud. So what we're hearing in the market is a number of different industry challenges where the intelligent track and trace application can offer some help and provide some value. The first is around just providing the investors assurance that the products that are being produced and mined are being produced in a sustainable and ethical practice. With the track and trace application, we provide a level of transparency and visibility to provide that level of credibility to those investors. The second area is just around transparency and governance. So a lot of the projects could involve partnerships, could involve joint ventures, which will involve many different documents that need to be reviewed by multiple parties. As different steps in the process get completed, it may involve the approval so that different expenditures could be released. So that level of transparency and visibility is another area where track and trace can help. And then third is just the modernization of core technologies. So we recognize that there could be many different disparate systems, data not standardized, not normalized. How do you bring it all together so everyone is really looking at the same source of truth? So with the intelligent track and trace application, it's giving, the aim of this product is to give you a digital supply chain twin to track any item, whether it be an asset or whether it be a transaction of value. So whether it be a new part, whether it be a replacement part, whether it be a new order, where you need to have visibility in real time to the production, to the delivery, to the receipt of such an item, or with respect to a business process, as transactions are completed and executed, it gives you the level of transparency to track each of those assets or transactions as they move through your supply chain. So if we talk a little bit about the capabilities to give you a little more clarity on how this product works and the scope of the functionality, it really starts with a private business network or a private trading network. So being able to establish who are your trading partners, who are your suppliers for your parts, who are your logistics providers responsible for delivering the parts, where are the sources of them, and allowing you to create that environment so that they're all connected and you can visualize it. Data is a critical part of this. So we recognize that data could be coming from many different sources, including the IoT data that's coming in the form of whether it be work orders or maintenance orders, as well as other documentation data that's coming from partners. And when that data comes in, you have the ability as part of this product to standardize it. So when you're looking at a work order, it's going to look the same every time. When you're looking at a shipping document, it's going to look the same every time. And it's a very flexible approach here. So you would define what's the data you want to capture. And this is built on top of a blockchain-based technology. So the data that you've identified that's critical to record in a distributed ledger that's immutable and can represent an auditable history is also captured and defined at this step. With respect to modeling the business flow, what is really important about this part of the product here is you can set a standard of what you expect to happen. So if you are, for example, have a business flow where you know step 1, step 2, step 3, you define each of those steps, and it gives you the ability when something does not go to plan, then you have a clear baseline to measure it against, and then that can create actions to take when that happens. When the different supply chain milestones and events occur, we are capturing them all and we are correlating them so that you have the ability when you go in and you look, for example, for a particular maintenance work order. We would at that point have connected all the dots. So every transaction linked to that. So for example, maybe there was the placement of a replacement product, which involved other documents, other steps, other partners. Simply by putting in the work order, the product would have connected all those so you can see the different flows and the different steps to trace the entire flow of the replacement product. And as this data is captured, we are creating a digital thread. So you have a chronological order of every event and milestone that occurred, a complete audit trail with links to all of the relevant information and documents. And then in terms of monitoring the supply chain transactions, you have the ability to create a number of different actions when something doesn't go as planned. Actions could be involved in in-app notification. It could be sending an email to a predefined distribution list, or it could be webhook callbacks where you have integrated with other systems that you want to take the action to drive some other further action in a different system. So if we briefly just look at a few examples of where track and trace can help, the first one is around financial. So anytime you're involved with tracking the location of high value goods, being able to track the key milestones all the way from the time they're sourced to the time they're delivered, any change of ownership, and a lot of times tracking at that level of granularity is important to release payment. With respect to lease management, as I mentioned at the start, in terms of being able to capture all the transactions, providing visibility across your different supply chain tiers or different partners to those transactions, and monitoring those largely around the release of expenditures. With respect to protect from damage, so we are capturing telemetry type signals into the track and trace application. So if you have a new product or a replacement product that's subject to external factors like being dropped or high temperatures, that's another signal that can be captured and be used to alert you when a threshold is violated, to give you visibility when something happens, or if you're doing some type of root cause analysis upon receipt. In terms of new order fulfillment, so if you're placing a new order and you wanted to have a level of visibility that goes all the way back to the manufacturing and getting visibility to different supplier tiers, all those different parties, multi-enterprise visibility, multi-supply tier visibility is also something we can capture within track and trace. And the last one I'll talk about here is just around replacement parts. So we recognize that a lot of times these parts are being shipped to remote areas. It's really important you know exactly when they're going to arrive because of the cost of downtime. So having real-time visibility to where it is in the supply chain and when it's going to arrive is something else where track and trace can help. So in summary, when we talk about the track and trace application, there's a number of different areas that provide a lot of value. First, around transparency. So this is multi-enterprise visibility and the normalization of data across different systems and partners. Verifiable with a trusted digital audit trail. So you have every event and milestone associated with your supply chain flows and the timeline associated with those. Actionable, so being able to predefine rules and conditions of when you want to be alerted, really managed by exception. And as I mentioned before, there's multiple ways to be alerted: in-app, email, SMS, or webhooks to integrate with other systems. And then accountability. And this really kind of goes back, as I mentioned, with the technology built on top of a blockchain technologies to ensure that we give you the ability to define what are the critical fields that want to be recorded in a distributed ledger so that they cannot be changed and they're very referenceable with respect to accountability. So thank you very much.
Thank you, Aaron. We will now hear from Christian, Oracle Cloud Sales Executive, and Dathan Goff, at Senior Solution Consultant from rfsmart. They will be speaking on mobile supply chain and maintenance that will include a brief demo. Please welcome Christian and Dathan.
Thanks, Wade. Thank you, everyone, for attending. Welcome to the webinar. Basically, I'm going to talk today about rfsmart solution for mobile supply chain, Oracle SCM Cloud. It's a small piece of the puzzle, but it's an essential piece of the puzzle. We mentioned, we talked about all those different assets. Well, all those different assets have parts that needs to be repaired. And when you're in remote locations, how do you use mobile scanners to read the barcode labels and record the transactions in real time in Oracle Cloud? That's where rfsmart's come into play. Now, before we go further into what we do, I'm just going to mention who is rfsmart. So rfsmart, we've been in the Oracle ecosystem for more than 30 years. Initially, we started with JD Edwards, and due to our high customer satisfaction and expertise with implementing and supplying our software support mobile supply chain applications, we then partner with Oracle when they went to the cloud. Now, today, more than 75% of our customers are in the cloud space, and when Oracle decided to come up with Oracle Cloud about 5 years ago, they approached us having our expertise for many decades with Oracle and excellent customer success. They approached us to develop a mobile strategy to address, to extend their capability from inventory, manufacturing, maintenance, procurement, and more into the mobile area. Why mobile? Why is this important? Well, there's three main areas that we address, three main return on investments. There's the visibility, the accuracy, and the productivity. So you would certainly want to be able to view every type of inventory related transaction. You want to know who's doing what, who's performing, where there's areas that you might improve or change things. Obviously, you want to increase your accuracy. Doing manual process, it's error prone. So we want to reduce that to zero if possible. So eliminate as much as possible any manual data entry and increase accuracy up to 99.9%. And lastly, but very importantly, it's to allowing you to reduce the transaction time. Using a mobile solution will give you the ability to reduce the transaction time, and basically you'll be able to. We've seen cases where you increase productivity up to 20% or more. Like I mentioned, our solution, rfsmart solution, is already pre-integrated for Oracle Cloud. It's purpose-built for Oracle SCM Cloud, and it is to extend the capabilities of inventory, maintenance, manufacturing into the mobile space in order to allow you to allow the operators, the users of those remote sites where they have the assets, in order to use and transact using mobile scanners, read the barcode labels, and perform operations such as work order operations, issuing, receiving, and perform this in real time in Oracle Cloud. For the user specifically, they won't see a difference in the sense that we're using the same organization security as Oracle, the same data security, the same user authentication. So for the user, it's really the same username and password as they log into Oracle, and they'll be able to use our solution to update in real time Oracle Cloud. And we also support offline transactions for those remote areas where sometimes there might not be any connections. So before I pass it on to Dayton, today we're specifically going to address some of the transactions that we can perform related to maintenance work orders, in terms of being able to achieve that prescriptive and predictive maintenance that Simon talked about at the beginning. Transactions such as issuing materials, creating maintenance work orders on the fly, and identifying assets. We can also easily add inventory or manufacturing functions to a menu, perform transfer inquiries. And although we recommend rugged mobile scanners for those type of environments, such as in the mining and oil industries, we also support any type of modern browser, so we can also support mobile devices. So I'm going to pass it on to Dayton, who's going to be able to show you those different transactions and how Oracle Cloud is updated in real time.
All right. Thank you, Christian. So I'm going to jump in and show a couple of these transactions. You can see on the menu there's both inventory type functions, so we can do an inquiry, we can do those transfers and so forth. There's a whole plethora of functionality that's not listed here that's also available that would be useful for things such as receiving inventory. If you wanted to do the picking for the materials for a maintenance work order, we can do that through pick slip picking and so forth. But today the focus will really be on the top two. So the ability to create the work order on the fly. This might be a corrected work order in the sense, right? You have the capability to go out and scan or select or type an asset number and go ahead and put some notes in so that that work order is created, and then the definition can be assigned as appropriate. The second one is the ability to execute that. So that's that concept of going in and actually doing the completions on that, issuing materials or resources that are to be used or that are used on the work order. So let's start, and what I'll do is I'll kind of go circular with it here. I'll start with the creating of a work order. I'll take it out to Oracle. I'll show you what it might look like to assign a work definition, and then from there we'll actually execute that. So first things first, the simplicity of it is this. So remember, this is the corrective side where we're creating the work order. The first thing it asks me for is the asset. So if you have those barcoded, perfect. We can take advantage of that and scan it. If it's in text form on a label or something that's on the asset, we could type it here. there is the list capability. So there's a list capability here. You're going to see it on just about any mobile function that rfsmart provides. Is the capability to pull up a list and get a full descriptive list of those. In the sake of assets, that list might be long. So what I'll do is I'll spare it here. I'll show it on the maintenance execution side. But if I come up, I've got a barcode for an asset. If I give that a scan, what it's going to do is it's going to come through now, and you can see it pulled in this 3,000 asset. I can see the description of it. And now I get the ability to put in notes. So that note could be oil leak, flat tire, something along those lines. I'm just thinking from a perspective of maybe an automotive asset, but I'll just put something simple note, and we'll see this project into Oracle now. So I'm going to go ahead and submit that. We'll see a success message that pops up on the bottom of the device that lets us know that we've communicated with Oracle. It liked what we had and it submitted that. So for the Oracle side now, if I come out here and manage this, or look at my managing of maintenance work orders, I can resort this, and there's a new one out here. So it's unreleased, notice that, and notice my description follows through as well. So you can have that dashboard that shows me all of my unreleased work orders, and I can check on these throughout the day. But when I want to check on that, evaluate that, and maybe assign that work definition and release that, all I have to do is click on it. Notice it comes in. There's that description. Here's the work definition that's blank. I can select that. As I select that, let's do so and save it. It's going to ask me to go through some scheduling things. I'll go ahead and say yes. And as it does, kind of behind the scenes, notice here the operations, there's nothing there, but as I'm saving this, what it's doing is it's pulling in that work definition. And now if I take a look at that, if I jump over to that tab, you'll see there's two operations associated with this particular work definition. You see there's some materials or items associated to it. I don't have any resources on it. That doesn't mean I can't still issue those from the mobile device if that's my choice, right? We're not going to limit that, but there's just none there for now. So let's do this. Let's bounce back out and update this status to released. That release status is going to enable us to access that work order from the mobile device and begin the process of issuing and completions on that. So we've got it released. I'm going to bounce back out on the mobile function. You see the capability to execute my work order. So as I come into it, the first thing it's going to ask for is that work order number. Hey, if you plan to print some sort of traveler and hand this out, since we know it's there, you could do that. We could barcode that work order number and give users the capability to scan that. The other thing you can do, as I mentioned previously, was these list buttons are everywhere. So I can click that list button, and what it's doing is it's bringing back a list of work orders that are in a release status that I can potentially work on. And at the bottom, we see that particular work order that we've just created and released. So as I select it, it's going to pull in, and notice now it tells me, hey, you've got two operations for this. Which one do you want to work on? We see the statuses as well. So I'm going to go ahead and select that first operation. Now, once here, it's pretty simple. We've got three choices at the bottom, right? We can complete this operation. We can issue those materials. We can issue those resources. If it makes more sense to have your users select which one they want to do from a menu versus selecting it via a button, rfsmart can be configured to do so. So I could configure this to where when I come in, there's maybe a function, I call it issue materials or issue maintenance work order materials, and it'll take me straight to this screen. Once I select the work order in the operation, it would take me straight to this to where I can select those components to issue. So notice here, components, it's asking me. If I know if it's on my traveler, my piece of paper, I can go grab that, start the scanning process if it's barcoded. Otherwise, there goes the list again. So I can look at my list, and if you'll remember, item 1 was what's out here on the operation. I can select that from here. You see the quantities and so forth. Now, there are some things that we put in the background that you have the ability to select. We could only display components that are materials that need to be pushed. So when your supply type is push, meaning the worker needs to actually issue that, we can do that. We can hide things that are back flushed based on this work definition. So lots of configurations and capabilities behind the scenes that customers and users get the ability to configure, but rfsmart's going to execute the way it's configured. So in this case, notice it's telling me I need one of those. So as a user, I'll say, yep, I grab my one. And now it wants me to tell it where I'm issuing it from. So if you've defined that locator and supply sub inventory, that's fine. If it's on that particular work order, I have the ability to put that information in the definition here. If I do that, we don't have to prompt for this, but in my case, I didn't, so I need to tell it where I'm issuing it from. So maybe I'm behind the maintenance counter and I'm picking these. I tell it where I grabbed it from. We know where to deprecate it from in inventory. Now, you see the success. Again, that's the response from Oracle. So what I'll do at this point, I'm going to go ahead and complete the operation. I don't have any resources. I know that. We don't track resources maybe internally. So I can go ahead and complete the operation. What we'll see is it'll loop back and say, okay, what's next? Well, if we look at the statuses, you'll see that operation 10 has been, or operation 1 here, sequence 10 has been completed, and op 2 is ready to go. So I'll come on into it, and we'll complete this thing out by looking at the materials. Again, because it's a list capability, I'll look at that, and you see now it's item 2 for the quantity of 2. I have the ability to select. I'll back up, though. I'll take advantage of my scanning capabilities, and I'll scan a barcode for item 2, plug in my quantity. I can tell it where I want to do the supply from. I've got some defaults on this as well, but I'm going to overwrite that. I'm going to scan a different locator. And as I do, it'll issue from the one that I scan. And on that, complete the operation. So from a mobile perspective, the execution of it can be easy. It can be as simple as you'd like it to be for the user, but the value is that you get to do these creations of those corrective type work orders directly from the mobile device on the fly, and you have that ability to complete these in real time. So if you're looking to manage what's going on from the maintenance perspective, you'll have that visibility as your users do this in real time. All right, so that concludes the demonstration, and I will stop sharing now, and I believe we have another survey question.
Yes, thank you, panelists, for your presentation. We will now have poll 2. And poll 2 is, how can we follow up with you? Please feel free to select any option there. You can also select multiple options. All right, we'll close the poll. Now it's question and answers. We will now open it up for questions. If you have any questions, feel free to put them in the Q&A section in the webinar. The first question that we have is for RFSmart. Can you dispatch or assign a work order to a specific person?
Yeah, I'll take that. So within Oracle, you do have that capability to assign to a user. When users log into RFSmart, we know who that user is, right? They're logging on with that Oracle credentials. So yes, we can filter those down. That list that I showed with the work orders that were out there that were available to work on, we can filter that down by what's assigned to an individual user. So yes.
All right, thank you. The next question is for Trinamix. Can you plan for inventory to support our MRO?
Yes, Oracle has supply chain planning cloud as a module, which can very well support planning inventory for MRO and spare parts.
All right, excellent. And the last one with Oracle, what have you seen in deployment time to start receiving IoT data?
I'll take that if I can. Very quickly, actually. I mean, the key thing is how quickly can you get to something that shows the proof of value to your executive management. All too often, IoT projects end up sort of working more of a sort of focused on devices and unclear what business outcomes folks are trying to achieve. Where we've worked with folks with the right level of engagement within the customer, you know, the right level of sponsorship, and there's a clearly defined business outcome, looking to reduce time to fix, or looking to improve customer service, etc., where it's measurable. I mean, we've actually, using the simulation capabilities in the IoT intelligent applications, we've actually seen folks get to a live demonstration of a POC or a proof of value within a matter of 2 to 4 weeks. The other benefit of that is obviously then they can, using the simulator, they can simulate the data, they can start to generate predictions, they can start to show how the flow of predictive maintenance, they can start to play what-if type games with the applications. And then when it does come down to, what do we need, what capabilities do we need at the that whole experience has informed it, rather than, in that case, when folks start with the sensors, it can be a little bit of a stumble in the dark.
All right, thank you. Just one last check to see if there's any more questions. Oh, here we go. I got one here. Can a work order be assigned levels of severity or urgency, and are they organized by asset? For example, if a work order is created for an asset that has an outstanding issue, do they link to avoid duplication of effort?
Yes.
Oh, do you want to, sorry,
Go ahead, Simon. Go ahead.
No, there you go. Well, so within the IT intelligent applications, when we detect, or when the system detects that an asset is basically has generated an incident, that asset then becomes unavailable. The automatic, the out-of-the-box integration with Maintenance Cloud basically sends the work order through to Maintenance Cloud. The workflow to define the maintenance tasks for that asset are conducted in Maintenance Cloud, but updates are sent back, so it's visible within the appropriate IoT, the module within the IT intelligent applications. And IT intelligent applications will not release that asset to be available again until such time as that workflow has completed. And if the asset continues to generate new errors, etc., it won't necessarily impact the status of the fact that the asset is unavailable. It won't just keep erroring and generating work order after work order after work order. Sorry, Vanu, do you comment on that?
Simon, you have summarized it pretty well, but to add to that, even in the work orders can be assigned to a particular asset serial number as well.
Okay. Well, thank you very much. In conclusion, IoT and machine learning can have a major preventative impact on your assets, providing a way to proactively resolve potential issues before they shut down production. We have learned that making an investment in these technologies could save companies from unplanned downtime that costs companies millions of dollars. It was a pleasure having you with us. This concludes the webinar. Thank you all for attending. We hope that this has enlarged your understanding of IoT and preventive maintenance, and that you've enjoyed the presentation. Feel free to contact Oracle, RFSmart, or Trinamix if you have any questions or comments. Good day.